Did you ever look up and wonder, what is that bright thing in the sky? Do you wonder what would happen if you fell into a black hole? You have questions, and Mazie has answers. Join us now as we ask, "Hey Mazie, what's up?" This week, dark matter, fact or fiction?
Hello, Mazie here, and today we're talking about dark matter. Now, dark matter is basically matter we can't see, can't detect it, it's just invisible. Reason we think that all of this weird, invisible stuff exists in our universe, basically the galaxies are rotating too fast. Now, fast in this case means one rotation every 300 million years, like the Milky Way. But still, that's fast enough for a galaxy to start falling apart. But that doesn't happen. So, obviously, galaxies are a lot more massive than we give them credit for. So, where does this mass come from? Well, there are two basic ideas for what dark matter could be. One is massive compact halo objects, which are basically Jupiter-sized rogue planets, basically, which are far enough away from the stars that they don't interact with them, don't reflect any light, and so we can't see them. The other major idea of what dark matter is are weakly interacting massive particles, which are things along the lines of neutrinos. A neutrino can go along its merry way at nearly the speed of light, but not quite because it has a little bit of mass, for about a light year through solid lead, and only have about a 50% chance of actually running into anything. Now, if there are more of these very hard to detect particles wandering around the universe, then that solves the mass problem. The massive compact halo objects are a less likely proposition, specifically because we'd be seeing them. If we had a lot of massive compact halo objects, we'd be seeing a lot of transient distortions, but we're not. So we don't have enough of those. So the weakly interacting massive particles are the ones that are more likely to exist. And for those of you who think scientists don't have a sense of humor, look at the acronyms. Okay, so what would the universe be like without dark matter? A lot later. Most of the matter in the universe is dark matter. And so, if we didn't have that stuff, the universe would be expanding far quicker, and galaxies would be falling apart or not spinning as fast. It would be rather different. Now, there's also this stuff called dark energy. It's even more mysterious than dark matter, because dark matter we can at least hope to detect at our present technology. Frankly, I'm not entirely sure how I would even start explaining dark energy, except for as really weird. Also, there are a couple of alternative theories of gravity, like modified Newtonian dynamics for one, that might work without the extra mass of dark matter, but frankly, I'm not going to get into that because it's pretty complicated and not that many scientists think, oh, the theory of gravity is completely different from Einstein's general relativity stuff and warped space-time. Okay, and I think that's everything.